Oke, selamat siang semuanya.
Siang,
Ah,
Pak.
dulu di sini ada beberapa mahasiswa nih ya. Nama saya Risman Adnan. Saya ngajar di FMIPA, bantuin Profesor Al-Hadi Bustamam. Sebelumnya saya lulusan S1, S2 Theoretical Physics di MIPA, S3-nya di Computer Science UI. Sebelumnya saya CTO di Microsoft Indonesia, juga CTO di Samsung Research Indonesia, saat ini di Kalbe Digital Lab. Oke, fokus riset saya saat ini adalah healthcare, AI for healthcare, IoT, robotic process automation, juga menyangkut blockchain. Course ini mengenai AI, ya. Kita bahas logistik dulu sebelum kita masuk ke materi pertemuan pertama. So, course ini dikurate dari banyak sumber, ya, dan sudah dideliver di UI cukup lama. Semua materinya kalian bisa akses di sorry, there is Ramzan here. I didn't see you. Apologize. So we will conduct the lecture in English because there is students who cannot speak Bahasa Indonesia. I hope you understand my English. Yeah, I'm not native English speaker, but I work in many multinational company before. In Microsoft, in Samsung, every day in the office we are talking in English. So I hope my English is good enough for all of you. So let me start with the logistics. So this is the material you will face, maybe 14 weeks ahead, not including the midterms exam and final exam. Okay, so this material is actually delivered in many university, including Telkom University before. Yeah, why this is a robotic here? Okay, wait, I think there is some misplaced here. Okay, later. Okay, so we will follow the storyline in this book. This book is delivered by Alex Mola team in AWS, Amazon. Yeah, so Professor Alex Mola and his students make this material, and this material is already adopted by 500 universities from 70 countries. Okay, we also take many materials from CS231 in Stanford for computer vision. So if you want to learn more about computer vision, you have to learn this course. What happened? CS231, yeah, this one. And for the NLP, we are curating the material from CS224N. Okay. The Stanford course is very important for you if you want to take your research on NLP or computer vision. But as a main materials, we will follow the storyline here. Yeah. So today I will explain the introduction, including linear regression problem and curva fitting problem. And next week, we will learn about neural network for regression and classification, including the multi-layered perceptron. So 3 chapters next week. This week is only introduction part, yeah? You can read the material here, or you can follow the material that I prepare here. So can you see my screen? Okay, let's start. So I want to explain about machine learning problem for all of you, okay? And then I will illustrate the material using simple regression, linear regression, and polynomial curve fit. And then I will introduce the tools and framework that you need to master as your homework during next week. Okay, So let me start with the learning problem. So many terms people use to explain this problem. They use data science, data analytics, business intelligence, machine learning, artificial intelligence. They give all name to the same problem. But actually, the learning problem that we are talking about is how we can automatically find patterns, regularities, or knowledge inside data using algorithm. Okay. For example, you want to classify data into categories, or you want to cluster data. So classifying and clustering is a common learning problem. So you have data, there is a patterns inside in terms of categorical or in terms of cluster, and you want to find automatically the patterns. Okay. So make sure you have a clear definition of machine learning problem. The essence of machine learning is only three things. First, you need pattern inside the data. If the data have no patterns, so you don't need machine learning. We need machine learning because there is pattern inside the data. Okay, so for example, in current election in Indonesia, there is president candidate number 1, 2, 3. Okay, we have 80 million data. So there's a pattern inside data in terms of who will win the election. Okay, so we can use machine learning problem to predict who will win the election if we have enough data. Okay, so in terms of election, we don't need the whole data coming. Actually, if the total data population is 80 million for the election, maybe at the 20 million or 10 million, you already know the patterns. And the statistical pattern doesn't change after you add more data. Okay? Of course, we assume the data is correct. Yeah, my statement doesn't work if the data is manipulated. Yeah, so we also need machine learning if we don't have mathematical or analytical solution for the patterns. If one of you say, I can make the rules or formula, mathematic formula of the patterns, so we don't need to learn from data. What we need is the mathematical formula. But if you don't, nobody can make the mathematical formula, and all of these three essence is there, so you will need machine learning. Okay. So initially, we use machine learning techniques for problems that hard for human. We call it, let's say, data science or big data analytics, data mining, or whatever the term. But currently, we use this technique for problem that hard for computer, but easy for human. Let's say to recognize object visually, recognize text, yeah, NLP or computer vision. So currently we call it artificial intelligence, but it's just industry term, yeah. So I'll give you example, Netflix. I hope you like Netflix like me. There is 100 movie in Netflix, okay? So long time back, they run a competition for recommendation system. They give you data set 1 million rating from 480 users, 80,000 users from 17,000 movie. So the training data like user ID, movie, and its attribute data of grade or rating, and the grade. And then they have a test data, okay? They run this competition because their rule-based algorithm is no longer be able to give better recommendation. So if you win the competition, you will get $1 million, okay? So viewer have their past history, like they like comedy, or they like action, they like blockbuster, or they like Tom Cruise. And the movie also have the attribute. So imagine these two factors. If you have new users, what movie you recommend? or if you have new movie, who you will recommend those movie. That's the problem statement. This problem is solved by using many techniques like collaborative filtering, matrix factorization, random initialization. All of these techniques is a mathematical approach. Okay, it's about low-rank matrix factorization from the table dataset rating that you got from Netflix. You have to factorize the matrix into users and movie, and from this factorization, you perform some optimization to make sure that the factorization, the low-rank matrix factorization is the best factorization you can make. So if you have new users, you can see from this factorization what movie you can recommend. So this problem is very hard for human to do, but very fast and easy for computer to do. Okay? But what about this problem? I give you sample MNIST data set, and then I ask you what digit you see, 0 to 9. Very easy for human, okay? This is 0, 1, 2, 3. But if I ask you, make a computer program to classify a picture, whether it is 0, 1, 2, 3 to 9, you will get very hard problem, okay? Because the rules is not easy to define. You need mathematical model like SVM or neural network or any machine learning model to be able to classify this digit based on the features. Okay, so based on those explanations, let's formalize a little bit our learning problem. I will give you example or metaphor in credit card approval in banking. So let's check. Let's say X is a customer application, the form that you fill when you apply credit to the bank. Many forms, you have to fill the forms, and then you submit. That's we call X. Okay? And then the output is accepted or rejected, good or bad customer from the bank loan analyst. So let's say we have many training sample of X and Y, let's say 100,000 customer of the bank. This becoming machine learning problem if we say there is a function, unknown function F, that map X to Y, that map the data to the label approve or reject. The problem with F is nobody know F. It's unknown. Nobody will ever know. Nobody know. Yeah. And then what you can do with that? What you have is only data. Okay. Historical data of 100,000 N here. Okay. So if someone in the bank say, I have the rules. Yeah. I know F. If that is the case, that is not machine learning problem. That is rule-based problem. But if nobody in the bank, because of the government regulation changing every year, and the data is coming from many years, so nobody can define F. The machine learning essence is accept this problem as a machine learning problem if F is unknown, no mathematical formula. The second is how big N? How many N sample I need? Machine learning doesn't need the whole data in universe, okay? But to define how many N I need is really depend to your hypothesis set and your learning algorithm. Until now, there is no rule of thumb. If I use any model, I know N, okay? So the question like how many data I need to make this model works well, yeah? Theoretically, we only have few theory in that part. In mathematics, yeah, we call it Fisi dimension theorem. Unfortunately, for neural network that we will learn in this course, it's very hard to define Fisi dimension, Papnik-Sabinovsky dimension of neural network. So it's a hard problem to define how many data n we need for neural network. The short answer is neural networks need bigger data compared to other classical machine learning because neural networks have many parameters. Okay, I hope you already understand supervised learning in the context of this learning diagram. If you have complete data set, X and Y is the label, X is the data set or features. So we call the problem supervised learning because you learn from the example, because you have correct output or label, and you have the you have enough data set. For example, you have an email spam detector, you have the sample email and the label spam or no spam. But there is a machine learning problem is unsupervised, where you don't have the label. You only have the data set. In this case, you don't have the Y, only X. What you can do if you only have X? You can do clustering just to find cluster pattern inside X. You can do density estimation to estimate probability density that generate the X data. You can do dimensionality reduction, but only few you can do if you don't have the label. That's problem we call unsupervised learning. Another problem and machine learning problem is reinforcement learning. This is another problem, yeah? So what is reinforcement learning? So imagine you play chess, yeah? Your next move is really depend to your opponent move. If he move his one item, then you will wait and see. So you will learn from the environment. In this case of chess, you will learn the environment of your opponent. And then you have to make decision, which is sequential decision, to make sure you eat their item or you win the game. Yeah. So we can say reinforcement learning is a machine learning problem to learn to make sequential decision to maximize reward or minimize risk. Okay. We don't have course of reinforcement learning in mathematics right now, but I will propose later on that we will have reinforcement learning course in mathematics department later on. Okay, so what we will learn in this course is mostly supervised and unsupervised. So if I say machine learning model is about hypothesis set and learning algorithm. The purpose of this learning algorithm and hypothesis set is to find hypothetical function G that can estimate F, but never same with F. Okay, so G, the final hypothesis, will never be the same with F because F is unknown and will never known. Okay, so how many models we have? How many hypothesis set and learning algorithm? So the beauty in mathematics, machine learning is only about Papnik-Sabinovsky theorem, bias variance theorem, complexity and Bayesian theorem. Only 4 theorem, maybe 5 if you put optimization as a part of the theory. So in mathematics theory, a very few, only 5. Fisi, bias variance, complexity, Bayesian, and optimization, or sometimes we call convex optimization theorem. The problem with machine learning and AI is so many models, so many methods inside the model. So models like linear model, neural network, SVM, Newton's number, method like regularization, validation, aggregation, normalization, etc. Okay. So how you learn these complex things? Usually, we learn by understanding the concept and fundamental on few selected models. So in this course, we will focus on neural network for computer vision, NLP, okay? And we assume that you already know classical machine learning like SVM and nearest network. So artificial intelligence is about problems that easy for human but hard for computer. Like computer vision problem here, I give you image. I need you to classify which is cat or dog or duck. We call it classification problem. If I want to find the location of the cat, we call it localization problem. If I want you to count how many cat, dog, and duck, we call it object detection problem. If I want you to crop, to separate between object of interest like cat, dog, duck, we call it segmentation. Okay. So this is computer vision problem, basic problem, but now there is so many computer vision model that you can see in Hugging Face. Okay. For computer vision, the depth estimation, object detection, image to image, video classification, image classification, blah, blah, blah. You can also see in papers with code, there are so many computer vision tasks, maybe about more than 1,000 tasks. Okay. Be familiar with these two websites because as a researcher, this will be your best friend. Hugging Face and Papers with Code to find papers of your published papers. Okay, let me continue. So what about NLP problem? NLP problem, the data is text. Like ChatGPT, if you're familiar with ChatGPT, or speech. So in text and speech, there is a patterns inside the text and speech. And this pattern you need to extract. Before the time of AI or neural network, we do morphological analysis, syntactic analysis, semantic interpretation, discourse processing manually. But with AI and neural network model, we can do this automatically because neural network and transformer works better than your manual morphological analysis, syntactic and semantic. So inside this text and speech is about sequence. If I say a word is a factor, then there is a sentence is another factor. Okay? And there is sequence to sequence problem. For example, there is sequence one-to-one problem like machine translation. I give you a sentence in Indonesia. Can you translate to Hindi? Or maybe image captioning one-to-many. Or maybe sentiment classification many-to-one. Or many-to-many. Okay? So if you see in Hugging Face, there's a lot of models here. Okay? For natural language processing. Okay? And the model is keep coming. Okay? We will learn some of this model using Hugging Face. Yeah? But now there is another area open called multimodal. Means that the data coming from both text and image or video or speech. We call it multimodal. And in the future, most of AI will be multimodal. Okay? So papers with code, make sure you are familiar to search the topic in computer vision. You can browse here. Okay? State of the art. There's a leaderboard for many topics. Okay? You cannot understand every topic. So before you take this course, I hope you already decide what is your topic. Like, for example, you want to focus on medical imaging, or you want to focus on genomic AI, or you want to focus on other topics. But I hope during your master degree course, you can define what is your research topic. And this website will help you to get papers, codes, and data set. The same with Hugging Face, but Hugging Face is much more focused on transformer-based neural network. Papers with Code is open for any models, not only transformer models. Okay, spend your time with Hugging Face. There's a documentation here, and I hope you can learn from the documentation for transformer and NLP. So we will use Hugging Face Papers with Code during this course. Next. So to summarize our thinking framework, there is unknown target function f that map x to y. This is classification problem, okay? And you have supervised training data set. There is x and y. And there is hypothesis set plus learning algorithm, or sometimes I combine both. I call it model. So model equal to hypothesis set plus learning algorithm. The purpose of the model is to find hypothetical function g as a final hypothesis that estimate f. So let's pick an example, very simple problem. We call it polynomial curve fit. Let me start with linear hypothesis. I will give you animation. So you can play around. So there is some data here that already prepared. So I will use similar data. Let's say here. Internet since 1990 and total internet users and the year of 1990 above. So if I give you a problem, what is the internet user estimation for year 2025? So 0 is 1990. So 20 is 2010. So I extend to maybe 15 years above. So how you estimate? We call this problem regression. We use hypothesis set. What is the hypothesis set? I can use linear hypothesis like this line. I can try to find the line. Okay. Or I can use quadratic hypothesis, or I can use cubical hypothesis. Who decide which hypothesis we use? So we have to decide it. So in this demo, is only supported linear hypothesis. So I want to do regression, which is I want to define the y value, the target value. The features is x, okay, which is year since 1990. So how the algorithm works? Of course, you cannot do it manually. Very hard to do manually, okay? So how the algorithm works? It uses gradient descent algorithm to find minimum of residual. So you take all of the residual of the data to the hypothesis line, red line, and you minimize it, the minimum value achieved for A equals 0.1 and B equal minus 0.38. But minimizing residual is the same like minimizing square residual. So you square it first and then you minimize. Okay, so people now use error definition called mean square error. Okay, so this is the best line that you can find using gradient descent algorithm. Okay, in this example, you use linear hypothesis. What about if I give you another example using other hypothesis? So let's say I have this data. Okay, you can drag here. Okay, you can change the hypothesis to quadratic, or I can change to cubic. Okay, so who defined the hypothesis of the model? We as a data scientist or AI engineer will define it. There's so many hypotheses to define the pattern inside the data, not only linear, quadratic, cubical. What about support vector machine? What about decision tree? What about uh, all other classical machine learning? Or what about neural network? Okay, that's another hypothesis. So that is machine learning. I hope you play with this Pet Colorado for basic concept like this. Because when you learn neural network, it's still the same concept, okay? But the abstraction is different, okay? So I will give you these tools to play to make sure you can understand machine learning problem, yeah? So if we use hypothesis, let's say polynomial hypothesis, so we define the distance as a square residual, and we use gradient descent algorithm to find the minimum of total root mean square. Okay, in polynomial curve fit, you can get poor fitting, bad fitting, best fitting, or overfitting. What is overfitting? So poor fitting usually because you miss your hypothesis. Your hypothesis is not good. What we want is best fit, but what we want to avoid is overfitting. Overfitting means during the training, the accuracy is good, but if I give new data to predict, the accuracy is bad. Looks like the model memorizing the data. So as an AI engineer, we want to avoid poor fitting and overfitting. We want to have best fitting. So play around with Pet Colorado tools to illustrate this problem of overfitting, because that will be your enemy if you are doing machine learning. Okay, now I want to uh, make a program using ChatGPT, and then let's do the linear regression. Make synthetic data set for regression problem. Okay. And then write Python code to implement linear regression of the data. Okay. So I want to prompt the Pet Colorado style least square. Yeah. So instead of using predefined data, I asked the ChatGPT to make synthetic data set. I asked ChatGPT to write Python code to implement linear regression and then report the performance, the regression performance, and visualize the data and regression result. Okay. So you can use ChatGPT as your code assistant to learn linear regression, and you can use Google Colab. Connect If you need GPU later on, you can change the runtime to GPU, but I don't need GPU this time. But if you need GPU, you change the runtime to T4. You can get T4 for free. And now you can pass the code. This code using scikit-learn, generate random synthetic data, make the split between training and tests, perform linear model. You can also prompt for cubical or polynomial or quadratic, and it make prediction. They calculate the mean MSE, mean square error for test and prediction. And then they give you the report, and then it will give you the visualization. So if I run the code, then I will get this. Okay. If I run again, maybe I will give different, it will rise different data because it has a random seed here. Okay. So you can try this prompt after you understand from Pet Colorado. You can summarize the learning of this course that you can make your own linear regression, polynomial curve fitting. You can make cubical or quadratic curve fit using synthetic dataset. If you have your own dataset, you can publish here, make in CSV file, and you can change the code here to read the data, sample data from your Google Colab. Okay. So next, what about neural network? So we will learn more next week because next week is the schedule for neural network for linear regression and classification and multi-layer perceptron. But today I want to introduce you about neural network in a very high level beginning using simulation. So we will use tools called TensorFlow Playground. Please open these tools. Okay. You can open it. So here, let's start with the data. It provides you synthetic data set in 2 dimensions. Okay. And you can see the patterns. Okay. This is a very easy to split patterns, yeah, because it's forming a cluster, it's well separated cluster. This pattern is like circle. This pattern is like cross. Okay. This pattern is spiral. It gives you 100 data set. You can choose how many you want to use for training and testing. You can give more noise, okay, and batch. Okay, let's fix the batch as it is. So if the data is only in 2 dimensions with 2 levels, that's why the features is only x1 and x2. X1 is the value of the vertical and horizontal Cartesian coordinate here. So let's say I will start here and I will use only single neuron in the middle. I will use ReLU activation in terms of Tanha. You will learn about this next week, okay? And then you split the data. What you see here, one single neuron can represent line in 2 dimensions, okay? If I change the data to like this, one single neuron will never be able to split, to separate or classify the data because one neuron is only one line. Stop. So how to handle this pattern? One neuron is one line. What about if I give it 8 neurons? I can give 16 if I want. If one neuron can perform one line, then 16 neuron will perform 16 line, will combine as a polygon. Okay. With the same model, can it split this? Yes. Can it be used for this? It's quite hard. Maybe I need to add more capacity. Okay, so it can work. So this model is quite brute force because if I'm a genius mathematician, I will say you don't need more to get more. I will split this. I will reduce the hidden layer. Okay, I will I destroy the simulation. Let's start from beginning. Okay, I'm here. I just say, I just want to use one neuron. But in mathematics, we know about feature space, function space. What about if I add more features with single neuron? Initially, you cannot do it with single neuron and two features. But I use quadratic features, cross features, and sinusoidal features, and I train it. Can easily make a circle. What about this? Can easily make a cross. What about this? It's quite hard because the function space that you get from these features cannot accommodate this spiral pattern, okay? But if I add more, it can easily find. I stop. So you like the simulation, you learn, get your intuition. If you prefer to the code, you can use ChatGPT prompt, make two-dimensional synthetic data set for classification. Write PyTorch code to implement neural network with pre-hidden layers. Better you classify this data set to be for two-level classification, yeah, because, or you can say binary classification, okay? Write PyTorch code to implement neural network with three hidden layers, 8 neurons in each layer, learning rate 0.0, and ReLU activation. Report the accuracy and visualize the data and classification result. Okay. Okay, so I will give you this prompt and let's run the prompt. So I asked it use PyTorch. What is PyTorch? PyTorch is a library that we will use for AI. It's a very, yeah, it's like TensorFlow, but we will prefer to use PyTorch. Okay, so this is the code. So let's pass it to our Colab. So let's understand the code. It's data synthetic, created, convert it to floating point, make separation test, and then this is the architecture of the network. Okay. Make sure you understand this. You can map it to our playground before. Make a neural network, optimize using SGD. We will learn about this next week. Okay. And then it will plot the data. So let's run the neural network. Oops, there is error here. Number of, and you can say to here, found this error. Please fix the code. Okay. So I hope it can fix itself. That's the purpose of AI. Yep. So you can ask the AI to make you the code if you understand what you ask. So please play around TensorFlow as your homework. If you don't understand PyTorch, make sure you learn about PyTorch this week because we will use as our default framework. So the material for this week is just that's it. You can read this book. Next week, we will go to chapter 3, 4, 5. Okay, so that's it from me. If any question, please press just talk. Any question?
Sir, so for this course, the topics that will be focused on is like uh, is natural language related to natural language processing and then image processing, right? I just want to clarify that.
Yeah, we will learn computer vision and NLP, but we will not too deep. So if your research in computer vision, I mentioned before, take CS231 as additional course, okay? If your course is about large language model or your research is about NLP, please take 224.
So when I took the data mining courses in the previous semester, you mentioned that there would be graph neural networks topics will be discussed. Well, would it be discussed in this semester?
Graph neural network will be discussed in data mining, not in deep learning.
I see. Okay.
So the syllabus of deep learning is D2L material here, right?
I see.
Yeah, last year we cannot cover reinforcement learning because the time. So usually we stop at the transformer. Okay.
Okay, sir.
Yeah.
Sir, in order to work with Fundus images, image processing, what we need to learn, which courses we have to take as a background?
You just need mathematic background because you are in mathematics department and Python. If you
Yes.
think if you think you need to learn Python, go to Kaggle
Yes.
and just take the course of Python in Kaggle. Okay.
Kaggle.
Kaggle, yeah.
Yes, sir. And sir, when I was reading paper about Fundus images, they use CNN or NN. Will it be discussed in deep learning or not?
We will discuss convolution neural network, recurrent neural network, attention and transformer in this course.
So I don't need to learn it separately. It will be covered in this course.
Yes, I just need you to learn Python
Yes.
and mathematics.
Okay, sir. And any
We will follow this syllabus D2L, yeah.
yes,
So
I just opened in my laptop. I'm seeing it.
okay, good.
Sir, in mathematics, is there any specific area I have to, because mathematics is so big, so is there a specific area I have to target?
Actually, you need to understand probability, statistic, and optimization like gradient descent. but it's
Okay, okay.
course.
Okay, sir. Thank you.
But if you want to going deeper, I think it's worth to explore probability theory in mathematics, convex optimization theorem in mathematics, and also statistic. All we
Well,
all we learn in deep learning is all about those three.
okay, for probability and statistics, I have already taken courses in my bachelor's and now we are taking, but optimization, I have never heard of this. I will try to learn this.
Yep.
Yes, thank you.
But you can learn from this book, yeah? The preliminaries of linear algebra, calculus, probability statistics is covered in chapter 2. But
And
I will not repeat that course because you are in mathematics.
yes, sir, we will already, I will check it myself. Is it enough to just like learn this preliminary?
This enough. This enough, yeah?
Okay, okay, sir. Thank you.
Chapter 2 is enough, but I want you to be able to prompt to get the code from ChatGPT, yeah?
Okay.
So you don't have to memorize code, you don't have to worry about the code. Because in AI,
Hmm.
we reproduce the model that already done. We are not developing model ourselves, okay? Because it takes
The
PhD to do that.
the same thing I was, sorry, sir, is taking a little longer. Previously, I went to bioinformatics lab. There was some meeting, and I asked the same question from Miss Devi. Should I need to develop my own model, or I will work with the previous model with a different data set? And then she said, no, you have to write the code yourself and this thing. And I was worried, like it is going to be difficult to develop my own model.
Now, if you have PhD time, you can develop your own model like what I did before.
Yes.
But for master degree, I think you can tweak the model or modify the model instead of writing from scratch.
So
It's,
only I just need to do some modifications to the model.
yes.
Okay, sir. Thank you so much.
It's very hard to build the model from scratch because you need to spend money for GPU. Yeah,
Okay.
very hard. Too
Okay. Okay.
expensive for you guys. Yeah. So what we will learn in this course, you will learn state-of-the-art models and use it and
Sir,
modify.
can I ask one more simple question?
Sure.
Sir, as our graduation requirement needs to publish one paper,
Mhm.
so what does it mean? We can reproduce a paper or some results from a paper and publish in our own paper, or is it enough, or we have to do our own research on something? And like you previously mentioned that we can take some one other's model and we can modify it and regenerate the results and then write our own paper. So is it enough, or we have to go some other way?
My suggestion for master degree, don't make,
Yes,
yeah, because new model take you GPU cost, which is you may cannot afford to run so many experiment.
yes,
Second is don't create your own data set because yeah, if you're working in healthcare domain, it will
yes.
cost a lot.
Yes, sir.
So
I was trying to get data from Pakistan from some hospital, and it take around 2 months, but no response, and it's so many difficulties.
yes, so use public data set and use state-of-the-art model. But what you can do at your master degree is modify the model to get better performance, okay,
Yes,
to get better features. Uh,
yeah,
so don't spend time on making model because that is PhD usually. Like
yeah,
you review all of the state-of-the-art and making new models. That takes 4
yes.
years. That takes 4 years.
Yes, sir. It will take a lot of time because we are beginners. First, we have to learn about these things, and then we will be able to do this. From
Yes.
now on, we are just confused about these things. We are
Yeah.
not able, we are not in position to develop our own. So, sir, will it be enough as a requirement for the graduation?
Yeah, as long as you can pass Key 1 journal, which is Key 1 journal doesn't require you only to make your own model.
Okay.
Okay. So let's say you pick genomic area, then you find out problem in genomic and find out models that fit to the problem. And then
Yes.
find data set in NCBI or in public data set. And that's already master degree. So you have to be realistic with your time. Otherwise, you cannot pass 2 years.
Yeah. Related to Fundus, I found one public data set, but it is very big. It's 68 GBs. So I will use that. But for the model, I am confused. Once I learn these models, what is LNN and CNN and RNN, then I will be able to do that.
Yeah, for if you're working with Fundus, you can work with the CNN or Fission Transformer model. Okay, you can find out in Hugging Face. There's a lot of computer vision here, and then you can find the latest one, modify, use your
Okay.
Fundus dataset, and then report as a paper.
I can just import from here or not?
Yeah, you can reuse data here instead of you train from beginning. You can fine tune. You can add more data. You can train using Hugging Face.
Okay, sir, this is a good tool.
Yep. This is the standard tools for AI engineers. So be familiar with Papers with Code and Hugging Face. Yeah.
I just opened this website and I'm here. I will log in, sign up, and then I will try to learn this.
Yes, there is a course here you can take in the document.
Course.
Yeah, there is a transformer library.
So, okay, I will learn transformer library as well because before the data set you provided, it need transformers, but I was not understanding what is this.
We will learn about transformer later on in this course. Don't worry.
Okay, okay, okay,
Okay.
okay, sir. Thank you so much.
Okay. So for this first week, make sure you familiarize yourself with Python. I give you the homework here to play around with the playground neural network. And next week, we will learn more about multi-layer perceptron for classification and regression. And then we will learn convolution neural net, and we will learn recurrent neural net, and we learn transformer and attention. And then you can play around with your Hugging Face project. Okay? Any
Okay,
other
sir.
question? Okay, we only have 1 hour per week in this course. So utilize at maximum so you can learn a lot from me. Every day I build AI models, so I'm not just academician. This is my daily job. So make sure you learn how can you prompt like this. You generate code with Python, with ChatGPT, but you need to understand first the concept and fundamental before you can make good prompt. Okay. For today, I give you this. Please copy in the chat room. And that's it for first week. See you next week.